Previous class we have seen reflection of light, echoes, and then reverberation of light, then uses of multiple reflection of sound we have seen, and this is one of the example of reflection of sound from the curved ceiling of the conference hall. It is from curved ceiling, it is just reaching to the all the persons sitting in the hall after reflection. Like this also, if source is kept at the focal point of the concave surface, it will be reflected parallel, it will cover longer distance. Sound can be sent in one particular direction to the longer distance. Why are the ceilings of concert hall curved? For proper reflection of sound to the every person. A range of hearing. You see the range of hearing, how much frequency we can hear and how much frequency animals can hear. All right. So for the range of human being, how much percentage, how much frequency we can hear, and which one we cannot hear. Okay. Audible range of sound for human being extends from 20 to 20,000 hertz. 1 hertz is 1 cycle per second, we know, 1 oscillation per second.
Yes, sir.
So children under the age of 5 and some animals, such as dogs, can hear up to 25 kilohertz. Means 20,000 hertz तक सुन सकते हो. 1 kilo is 1000 hertz. Children can hear the more frequency than the normal adults, which is up to 20. Even sometimes it is found to be less than 20,000. Even what I find, I was testing. I was not able to listen more than 18,000 hertz. So you can download and listen the sound. Shall I show you the sound of high frequency? Let me see whether I have. Okay, yes, it is. So let me see. Okay, I'll just play the sound of lesser frequency. Let us see 20, starting with the 20. Okay. कितनी है lower range? 20 है. Okay. Are you able to listen something?
No, sir.
Okay. Now.
Yes, sir.
Okay, I'm increasing now. It is
Yes, sir.
372, 691. It is more than 1000, 1500, 17, 2000, 22, 2400, 3000. It is 4000. Are you able to listen?
Yes, sir.
5000 is this. 7000. It is 10,000 now. Are you able to hear it?
Yes, sir. A bit.
10,000. It is 12,000 now.
No, sir, not audible.
Not now.
Okay. Now it is okay. Just I will Now, just let me use the earphone and let me bring it near to my earphone. Just wait.
So,
Hello, sir.
Okay. Can you see the screen now?
Yes, sir.
yes, sir.
Okay. So you can just download the app and here and tell me up to what is the maximum range you are audible.
Sir, can you
Generally,
repeat?
it sorry,
Sir, what's the app's name?
app's name. Let me see what is the app's name. Frequency.
Okay, sir.
App's name is Frequency. Are you able to hear now?
Not now, sir.
It is just after 12,000, it is becoming very faint. I don't know why. Okay. So human beings maximum are, it can go in normal range is 20 up to 20,000, but for children it is up to 25,000. And for and below 20 hertz, frequency below 20 hertz are called frequency below 20 hertz are called infrasonic. Infra means less, inferior. Sound say inferior means we can hear up to 20. Less than that frequency called infrasonic or infrasound. So ये जो है, how do you pronounce it? Rhinos communicate using infrasound of frequency as low as 5 hertz. They can communicate up to 5 hertz. Whales and elephants produce sound in the infrasound range. Whales being so large, elephants and whales being large, they communicate at the lower frequency. It is observed. Even I have heard that the elephants can communicate many kilometers away from each other. Is it true? They're able to
Yes,
communicate
sir.
being okay. Why? How? Why? And how? Because of less frequency.
Probably. Yes, sir.
It is it is observed that some animals get disturbed before earthquakes. Earthquake produce low frequency infrasound before the main shock waves begin, which possibly alert the animals. Animals come to know that there is the chances of earthquake because earthquake initially the waves comes infrasound waves comes. Later on, the major shock wave comes. Okay. The animals come to know. They get the warning before the main earthquake. They can identify, in fact. All right. Frequencies higher than 20 kilohertz are called ultrasound or ultrasonic sounds. Ultra means more. Ultra means more. It's ultraviolet. Ultraviolet have got the frequency more than violet. Or infra means less, like in infrared rays. Rays having the frequency less than red color light.
Yes,
They're
sir.
called infrared. Similarly, infrasound, ultrasound, or ultrasonic. All right. So in infrared rays we cannot see. We see red colors and more higher frequencies. Infrared remote controls use the infrared frequencies, for signals, for just communicating the that signals. When we press the buttons of remote control, they use the infrared, which are not visible to us, but with the help of cell phone we can see. Cell phone में app download करके we can see that infrared indication, infrared rays. Okay, so dolphins. Okay, ultrasound is produced by animals such as dolphins, bats, porpoises, moths of certain families. Have very sensitive hearing equipment. These moths can hear the high frequency uh, quacks of the bat and know when a bat is flying nearby and are able to escape the captures. Rat also play games by producing the ultrasounds. Many animals you see are insects. They are using the ultrasounds. ठीक है और कहीं अल्ट्रासाउंड यूज करते हैं
So sonography.
जो yes in medical science we use the ultrasound. Okay,
Yes.
this is a question we have to do. Sound waves travel at the speed of 339 meter per second. If its wavelength is 1.5 centimeter, what is the frequency of the wave? Will it be audible? So can you solve this question? Can we hear this sound whose wavelength is 1.5 centimeter? Tell me after calculation. How to calculate? Can you tell me? देखो कैसे करेंगे just find out. Is it ultrasonic or supersonic? Supersonic is what?
So
Supersonic we
faster
don't call
than
it.
speed of light, speed of sound.
Super
Sorry.
Supersonic is something else. Object moving faster than the speed
Yes,
of
sir.
sound is supersonic. But ultrasonic is what? What is the difference between both? Ultrasonic is what?
It is more than 20,000.
Frequency, sound
Frequency.
having the frequency more than 20,000 hertz or 20 kilohertz. All right. So
Yes, sir.
how to know this is ultrasonic or infrasonic, or can we hear it or not? Just find out and tell me how to find out. Yes. Aditya, how to do this?
So velocity equals frequency into lambda. So we
Okay.
get frequency 339 by 1.5.
Okay, देखो कितना आ रहा है फिर?
So 226.
Hertz.
सर सेंटीमीटर को मीटर में कन्वर्ट करना पड़ेगा।
मीटर को, yes sir.
मीटर में कन्वर्ट करो फिर।
So 0.01.
कितना आ रहा बोलो?
22,600
22,600 hertz.
hertz. So it will be
Okay.
ultrasonic. It won't be audible.
It is 4. It is coming 22,600.
2,600. Yes sir.
22,000.
It will be ultrasonic. And not audible.
To whom? To whom?
To us.
Humans.
Humans में child can hear है ना?
Yes sir.
Child can hear. कितना क्या child लिखा कि children लिखा?
Infants.
Infant. अच्छा,
Below
below 5 है ना? तो up to 5 years जो children
toddlers.
can hear it. They can hear, but we cannot hear it. Okay, it is. We can say. अच्छा, audible पूछा तो in general it is not audible है ना?
Not audible. Yes sir.
Not audible in general. Clear? So next one is questions. We see what is the audible range of the average given here. What's the audible range?
20 hertz to 20,000.
Okay, 20 hertz to 20 kilohertz. What is the range of frequencies associated with the infrasound?
Below 20 hertz, infrasound, and above 20 kilohertz, ultra.
Less than 20 hertz, greater than . Okay. Applications of ultrasound. So you know ultrasound in day-to-day life, they are widely used in cleaning the parts located in hard to reach places. For example, spiral tubes हैं, ऐसे spiral tubes होती, इसके अंदर क्लीनिंग के लिए अल्ट्रासाउंड यूज करते हैं. Odd shaped parts, electronic components, etc. Objects to be cleaned are placed in cleaning solution and ultrasonic waves are sent into the solution. Due to the high frequency, the particles of the dust, grease, and dirt gets detailed and drop out. These objects thus gets thoroughly cleaned. High frequency help us in detaching the dirt particles and which can be later on cleaned. So ultrasound is also used for cleaning purposes which are hard to reach. Ultrasound can be used to detect the cracks and flaws in the metal blocks. Metal block के अंदर जो है inside है ना, which we cannot see from outside. Internal cracks and flaws in metal blocks. Metallic components are generally used in the construction of big structures like buildings, bridges, machines, aeroplanes, and also scientific equipment. The cracks are holes inside the metal blocks, which are invisible from the outside, reduces the strength of the structure. Ultrasonic waves are allowed to pass through the metal blocks, and detectors are used to detect the transmitted waves on the other side. If there is even a small defect, the ultrasounds get reflected back in, indicating the presence of flaw or defects in the. Suppose यहाँ से ये detectors लगा दिए, इधर से ultrasound भेजी, defect और flaw, यहाँ पे defect है, यहाँ पे crack आ गया है, यहाँ से वापस reflect हो जाती है, because medium changes, so there is a reflection due to change of medium, है ना? तो यहाँ से reflect, this detector will not receive the ultrasounds, so they will come to know there is a defect in between, there is a gap, ear gap or hole or hairline crack, है ना? So with this,
So then how will they treat it?
they will remove that part, वहां से वो
Remove.
part निकालना
Yes,
पड़ेगा.
sir.
जैसे एरोप्लेन है, विंग्स है, कुछ है, बॉडी है, उतना पार्ट निकाल देंगे, दूसरा नया लगा देंगे, नया पैनल लगा देंगे, है ना? और अगर कुछ स्ट्रक्चर है ना, उसको भी फिर वहां से वो पार्ट निकाल के नया लगाएंगे वहां पे, फिर देन दे विल डिग दैट आउट. वहां पर सपोज बिल्डिंग है या कुछ फ्लाईओवर है, दैट पार्ट दे विल जस्ट डिग आउट, दे विल जस्ट dig it and make the corrections. Otherwise everything cannot be opened, है ना? उतने पार्ट को खोलकर और ठीक करते हैं. That part will be replaced. Reinforcement may be done, and suppose that part cannot be taken out, तो या तो reinforce करेंगे कुछ उसके हेड साइड में लगा के, या फिर they will
Okay, sir.
declare it as a that it cannot, मतलब
Defective.
उसको, हाँ, defective, that structure dangerous or cannot be used further, it has to be demolished. Okay. The ordinary sound of longer wavelengths cannot be used for such purpose as, again and again it is going to
Yes,
the,
sir.
what is the problem? Can you tell me? Network problem or Zoom problem?
A Zoom problem.
Okay. Today my Zoom is creating problem or other classes also? Okay.
शर्मा सर केस में नहीं हुआ था.
Screen sharing में थोड़ा problem आता है. If I don't have to share the screen, then
Yes, sir.
it goes on well. If I use the camera, but camera में फिर ये थोड़ा सा, you'll not be able to see. I will, okay, I'll see that is it possible with the camera. Okay, चलो आगे देखते हैं. Ordinary sound of longer wavelength cannot be used for such purposes as it will bend around the corners of the defective location and enter the detector. यहाँ से corner से bend होके ऐसे आ जाएंगे. So this is high frequency. So they will just get reflected. They have such property that they will be getting reflected from the part which is defective. Low frequency waves are just bending around the corners of the defective part. Ultrasonic waves are made to reflect from the various parts of the heart and from the image of and form the image of the heart. This technique is called ECG, echocardiography.
Yes, sir.
ECG बोलते हैं इसको. Ultrasonic waves are used there also, you know, to reflect from the various parts of the heart and form the image of the heart. So if image is distorted, means there is the problem in the heart. If image is normal, so it is okay. Sometimes heart shrinks at the old age, and they come to know whether it is shrinking or its size is okay. They are the medical science, medical people are best to know how to find out whether it is a healthy heart or, but this is making the image of the heart with the help of ultrasonic. It can be shown on the monitors or printout can be taken. The ultrasonic waves travel through the tissues of the body and get reflected from the region where there is change of tissue density. जैसा कि हमने ऊपर देखा था स्ट्रक्चर को जैसे चेक कर रहे थे, वहां भी डेंसिटी चेंज हुई, होल वगैरह होने से डेंसिटी चेंजिंग. In body also, if there is a change in density, then they get reflected. If tissues are uniform, they will not be. If density changes, so they will be reflected. These waves are then converted into the electrical signals that are used to generate the image of the organs. These images are then displayed on the monitor or printout taken on the film. This technique is called ultrasonography. Ultrasonography. Ultrasonography is also used for examination of
Yes,
fetus
sir.
during the pregnancy to detect the congenital defects or growth abnormalities. उनका जो है अल्ट्रासाउंड से जो शेप आता है उससे पता लग जाता है कि ग्रोथ प्रॉपर है कि नहीं है, और any hereditary problem is coming or growth problem is coming, abnormalities are there. So it can be periodically, they can be monitored by the ultrasonography. Okay. Ultrasound can also be employed to break the small stones formed in the kidneys into the fine grains, and these grains later get flushed out with the urine. So many uses are there. Ultrasound, even they are used to break the small stones inside the kidney. So this is good technique. Without surgery and all, they can be removed. The multi uses of ultrasound. Now, one sonar system is there. Have you heard SONAR? SONAR is the acronym or
Yes, sir.
abbreviated form of sound. SO, two letters are standing for sound. N stands for navigation. A stands for end. R stands for ranging. So sound and navigation and ranging. इससे रडार होता है ना, रडार में we use the electromagnetic waves, all right, and sonar and radar is for aeroplanes, whereas sonar is for the underwater objects. So sonar is the sound, navigation and ranging, and sonar is the device that uses the ultrasonic waves to measure the distance, direction, and speed of the underwater objects. Achha. How does the sonar work? Sonar consists of transmitter and detector, and it is installed in the boat or ship or submarines. Submarines के अंदर भी रहेंगे और boat and ship के ऊपर भी रहेगा as shown. यहाँ पर तो डेप्थ है, समझ, यहाँ पे डेप्थ है, डेप्थ मेजर करने के लिए दिस इज सी बेड, या फिर सबमरीन से, सपोज सबमरीन से पानी के अंदर, इधर एनिमी सबमरीन है तो उसको भी डिटेक्ट कर सकते हैं. They will send the frequency and it will be received. If received frequency is other than the actual frequency, they will come to know this enemy submarine is approaching or going away. If it is stationary, that also no change in the frequency received. When the moving of it frequency hits the moving object, then receive the frequency reflected will be changed. And change frequency will indicate whether the enemy submarine is approaching or going away, and what speed it is approaching, with what speed it is going away. What is that phenomena called? Change of frequency say, what is that effect called? Change of frequency. इसमें frequency change नहीं होगी, इसमें क्या होगा? It will go hit and come back. तो time note करेंगे इसमें. Distance covered is 2D. Velocity of the ultrasound in the water V will be given. Time will be noted after how much time it comes back. Then distance will be Vt by 2. V will be known. Ultrasound की speed जो है water में, it is calculated in advance. ठीक है. But what I was asking was different. जैसे aeroplane is approaching or going away from the airport is done by the radar. Similar to this, उसमें electromagnetic waves use करते हैं
Yes, sir.
which move with the speed of light. है ना, radar में जो है electromagnetic waves, and also the speed of the cricket ball is also measured by that phenomena. Frequencies are sent toward the moving object, and when they come back, so the frequency received is other than the actual frequency. This is called Doppler's effect. Doppler's effect in sound and Doppler effect in light. जब light means electromagnetic waves, तो उससे भी पता लग जाता है कि whether the object is approaching with what speed or going away with what speed. So that is the Doppler effect, which we are not discussing now. In this change of frequency का फार्मूला होता है उसका, हायर क्लासेस में पढ़ाया जाएगा तुम्हें 11th 12th में, है ना. बट यहाँ पे केवल डेप्थ निकालने के लिए यूज कर रहे हैं हम उसको. Our method is called echo ranging. The sonar technique is used to determine the depth of the sea and locate underwater hills, valleys, submarines, icebergs, sunken ships, etc. Suppose this is moving, ship is moving further, इधर जा रहा है, यहाँ पे दूसरा ship ऐसा sunken ship है, तो now they will find after some time the distance is less, so here is somewhere that either mountain is there or some sunken ship is there, with the speed, with the time, with the distance, they will identify what is the distance at various locations, whether it is mountain is there, underwater mountain, or sunken ship is there. ठीक है. So what about this question? Can you do? Read the question, understand it, and solve it. Speed is given, time is given. Use the formula. Are you getting it? Just tell me.
Sir, 2 into D equals V into T.
लो क्लोज आंसर निकालो.
Sir, 2.6 kilometer.
2.6 kilometers. The first answer coming. Others. Same formula. 2D. Once
Yes, sir.
distance covered will be twice. 2D total distance will be 2D into T. So D is equal to VT.
Sir, 2.681 kilometer. 618.
Okay. 1531 into. कितना रहा 2618 किलोमीटर centimeter meters है ना.
A meter. Yes, sir.
It is close to 2.618 kilometer. ठीक है. This is the right
Yes,
answer.
sir.
So easy questions है ना. What about
Yes.
this? Sonar devices and submarine sends are the signals receives an echo. 5 seconds later, calculate the speed of sound and water. Time is given, and V is asked, and distance of object from the submarine is 3625 is given.
So 1450 meter per second.
Yes. Same formula
So
again or
V
something
equals
else?
2D by T. Yes.
V is equal to
2D by T.
2 divided. We
Yes,
are
sir.
again going and coming back. So distance, one side distance is given. 2 into 3625 by 5. It comes 1450 meter per second.